Okay, so as a reminder, you can ask a question anytime. I'll try to keep an eye out on the chat, but because I only have the one screen up right now, I might miss it. So today we're going to talk a little bit about pneumatics. I might jump around between a couple of different documents here together. I should have, I'm sorry. I should have put together just one slide deck, but I didn't do that. So my apologies for that. This is the Ask Me Anything About Pneumatics from our training guide here, our training page on our website. There's some links to some other things as well in here that might be useful if you want to dive into it a little bit more. So I want to make sure that everybody kind of has an idea of what pneumatics are. In FIRST Robotics, pneumatics are air-powered cylinders, typically used to move something into one of two possible states. And so we'll refer to something, or we'll refer to the pneumatic system as being extended or retracted, typically. And then there are solenoids that are electronically controlled to direct the air cylinders. And then the cylinder is the thing that people will refer to as a piston, but it's really a cylinder with a rod. It's not really a piston. So, and then the solenoids are used to control the airflow within the cylinders. There's a thing called a manifold that hopefully I'll have a picture of later I can point out. And so a manifold is a piece of hardware that can reduce the amount of tubing needed to go between solenoids and all of that. And then air tanks are used to hold the air. So there's two different pressures to be aware of for air tanks. There's stored air that can be stored at 120 pounds per square inch or 120 PSI. And then there's a working pressure amount, which is 60 PSI or less. And so if when we get into the down and dirty of designing something, we might want to have some cylinders that are 60 or at the working pressure. And then we definitely want to have some tanks that are at the 120 PSI, because obviously we can hold more air if we have it at 120 PSI, but we want to make sure that the air is quickly available for some of these things. CV is a term for coefficient of flow, basically how much airflow can get through. And then SCFM, I should have wrote down what that is because I actually forget what SCFM. So it's something cubic feet per minute. So it's SCFM, standard cubic feet per minute. So those are some common terms that we'll see. I'm sorry, I should have had some pictures here and I just don't with that slide. But these are the cylinders kind of with a cutaway so you can see internally what's going on. You don't need to necessarily right now worry about all the details of it. If you want to come back and look at this, these are the different parts of a cylinder. In particular, these are called double acting cylinders. And you can tell that they're double acting because there's this port at A and this port at C. And so basically you have tubing going into both sides of it. And so you have air pressure either to extend the cylinder or retract the cylinder. So basically when air comes in this port A, it pushes the rod out. And when air comes in at port C, it pushes the rod back into its retracted state. Versus a single acting cylinder, you only have one port. And so the air is used typically to push it out. And then there's a spring that causes it return. So when that air is allowed to exhaust out the system, the spring pushes the rod back rather than having the force of air from another tube come back. So you can either get it to do a spring retract or a spring extend, but typically the spring retract is cheaper and more accessible. Any questions so far? Is that too in depth? Does that kind of make sense?
Makes sense.
Okay. So there's a bunch of other important parts when talking about pneumatics. I'm going to kind of skip over a lot of these right now, but they're just different things that you can attach to the rod to allow you to connect it into the system. This tube cutter is important because you want to get straight cuts. If you have an angled cut, you can end up getting leaks. And then this PTC is a push to connect. Basically, you take your tube and you push it into the connector and it gets fully seated in that way. There's a lot of different ways to mount cylinders. We won't talk about it too long, but basically you can have it where you mount it on the fronts. And so you've got this, nut basically that mounts it to the front. You can have a pivot in the back. And so you can see that there's this kind of rod sticking up in the middle. So you'd have that rod going through something. And so this whole thing can pivot around this axle, or a double end where maybe you've got both sides supported or either side supported. And there's also very tiny pneumatics, and we haven't really had a need for those yet, but it is something to be aware of. This is an important part of it, the solenoids. And so solenoids control the airflow. Like I mentioned before, they're electronically controlled. So we have wires that go to the solenoid, and then the solenoid has an output here. The wire comes into this part here, and then internally here, there's valves that open and close to direct airflow either to the manifold below it or to some ports in it. Let's see if I might have a picture coming up soon of internally what's happening there. I want to make sure everybody understands though. So there's, like I mentioned before, there's a single acting and double acting solenoid or cylinders. There's also single acting and double acting solenoids, but the two are not related. You don't have to use a double acting solenoid with a double acting cylinder, or a single acting solenoid with a single acting cylinder. We can kind of get into that a little bit more later, but that's really important to know. Really all you need to do, like we typically should use single acting solenoids unless there's a reason that we need to have the robot be disabled in both the extended or retracted state. Basically what happens with a single acting solenoid is that whenever the robot is disabled, all the cylinders would go into a default state. So we can talk about the design aspect of that a little bit more, but it's important to note that they are not really directly related. You don't have to use the same type for both. So internally to here, this is what's going on with a solenoid. So a single acting solenoid does not hold the position on disable. That's why I'm saying that typically we can use a single acting solenoid unless we need it to hold that position when the robot's disabled. We should by default use a single acting solenoid because it uses less ports on a pneumatics control module. Let's see if this video, I think this video shows internally what's happening when electronics, yeah. But let me make sure that I'm optimized for a video clip. We don't have to listen to anything that he's really saying right now. I just want us to be able to watch. So basically you can see internally here, this is called a 5-2 solenoid. And there it goes, there we go. So this A and B port go to the cylinder, and then there's this exhaust pressure line. So this is the air coming in and then another exhaust. So let's speed this up a little bit. So you can see right now, there's no path to anything here, or maybe, I don't know, let's watch this. So then when this solenoid turns on, we can now see we end up having this path from the pressure line to A, and so it's going to end up pushing the rod out. And we also have this path from B to the exhaust line. And so what happens is that this, yeah, there's the video there. So the air goes through A, it extends the rod, and then the air gets exhausted through the exhaust tube port. And then when the other one turns on, it pushes these valves over the other way. And now you can see that the B port gets pressurized from the line and the A port can exhaust out. And so I think that that was a really useful video for me to watch at one point to kind of learn what was going on. So if you want to go back and watch it on your own at some point and listen to the example, that might be something good to do there. Let's stop that. Okay. All right. There's also a pressure switch. And so the pressure switch is basically what turns off the compressor once you have 120 PSI stored. They're not all the same. So if we really needed to get really picky with it, we might want to test different pressure switches and see when it is that they turn off. We're not going to talk about a needle valve today or flow control today. That's all more, this is all more advanced stuff. So let's go over to spectrums and we'll recap probably a couple different things. This is a nice diagram kind of showing what's going on. So we have an air tank. This air tank is going to have, actually, let me start over here. So this is our pneumatics control module. And so this powers a compressor. This compressor is basically, generating the air pressure, and it's going to go fill this tank with air at 120 PSI. And then what happens is that there's this gauge that lets us know that it's 120 PSI. This switch goes to the pneumatics control module and turns off the power to the compressor once it reaches 120 PSI. And then this thing here is a relief valve, basically, so that if something wrong happens and it tries to fill it up past 120 PSI, this will automatically let air out so that it can't get any higher than 120 PSI. Once you have 120 PSI in here, the compressor turns off, nothing else happens until you send some power from the pneumatics control module to the solenoid. And then what that does is that opens up that pressure line like we talked about before, and either pushes air into the cylinder or pushes air this way into the cylinder, and then would exhaust some air. This guy here in the middle is the regulator. So you can see that on this side, this red tubing would be at 120 PSI, and this green tubing would be at 60 PSI or less. So that's a nice diagram showing what's going on with pneumatics. Here's some real life pictures of it. You can see this is a manifold underneath. There's a lot of solenoids all stacked together on here, and you can't really see it too well here. But there's this clear line over here is that 120 PSI coming into the bottom of this manifold. That pressure line is on the bottom, and then the A and B ports of the solenoids are on top. And so those would go off to the cylinders. We don't, hopefully, I don't know, we'll talk about this. So 1 atmosphere is the pressure of the air all around us. That's typically at 14.7 PSI if we look at it at an absolute value. When we exhaust one side of the cylinder, it means that that side will be at atmospheric pressure. And then let's see. We talked about being at 120 PSI. We talked about this stuff. The compressor feeds the air into the system. There are different types of compressors that we can use, but only one compressor is allowed on the robot. There's a link here if you want to see how the compressor works. We're not going to watch that today. And then there's this different tubing. And so tubing is definitely something to keep in mind. We typically use probably some smaller tubing. If we really need to move a lot of air through it, we need to make sure that we use the largest tubing that we're allowed to use, which is going to be the 1/4 inch. And actually, I think maybe that is what we typically use as the 1/4 inch. I think that's what we've got. The 532 is a little bit cheaper, but I don't think we've used that. We talked about to do 2 different gauges here. So that's reading how much air pressure there is. And the regulator, it is important to note that on the regulator, there is a diagram that shows you which way air is flowing. I've got a low battery, so I need to probably call this quits here. I'm sorry about that. hopefully just a quick lesson today is going to be okay. Any questions on anything?
Not really. I thought it was super useful though.
Yeah, so I think we should jump back into that next week. I've got a low battery and I don't want it to die in the middle of the meeting here. So